Hello, everybody, and welcome back to our third lesson in our blue book, Expressions and Equations 3. And we are on page 12, and this page will be notes. So applications, what that means is when do you use this kind of math? And so those are always good problems because a lot of students will say, well, why would I ever need to learn this? Well, this is maybe one occasion you might need it. We will write equations to solve problems. We will apply what we've learned about formal algebra to solve equations that involve rational numbers. So rational numbers are fractions. So I will show you how to deal with those fractions, okay? Any number that can be written as a fraction, then that's a rational number. It's also decimals that end or repeat. So a decimal that ends or the numbers repeat over and over, those are also rational numbers because you can actually write them as a fraction. Getting started, two friends, Sadie and Bettina, are both saving for the same phone. On their graduation day, Sadie received a $200 gift and Bettina received a $150 gift. How nice, right? Sadie will save $40 per week and Bettina will save $25 per week. So the starting points are the ones you need to underline. These are the startings. And then this per week means every week you're going to add $40. So that'll make the amount bigger, right? And this is the same, $25 per week. Yeah, so let's look at our table here. We have the number of weeks on top. Week 0 is your start. Week 1, 2, 3. So this is going up to 8 weeks, right? And then Sadie, on the starting week, she started out with $200. And she added $40 per week. So now the second week she'll have 200 plus 40 is $240. The second week, after the second week is over, she'll have, I'm always adding $40 to this number. 280. See if you can do that yourself without watching me. Up 40 each time. See if I did this right or if I made a mistake. Sometimes teachers do make mistakes, but I think that's correct. $40 each week added on to $200 gives you $520 after 8 weeks of saving. Bettina started out week 0, that's your starting point, with $150, and she saved $25 per week. So now I'm adding 25 each time. Try that yourself without watching me and copying me. You can use a calculator if you like, or you can do it in your head. Looks like Bettina is not going to have as much money as Sadie, right? $350 after 8 weeks of saving. Who started with more money? It was Sadie, correct? Write an expression for the amount of money Sadie will save after W weeks. So W is the number of weeks. So that would be these numbers, 1, 2, 3, 4, 5, 6, 7, 8. So the expression will look like this. You take the starting point, 200, plus we're adding money each week. We're not spending any, that would be a minus. We're adding $40. nope, $40 per week. So we want to use our W. W is the number of weeks. So this is the expression for Sadie. And now Bettina gets, she started with $150 and she saves. So we're adding, she's not spending any, $25 per week. So this right here is a multiplication part, 25 times the number of weeks. So let's say your number of week is 8. It would be 8 times 25 plus the 150 she started with, and you get 350. So no matter what number for the week you substitute here, you will get this answer. Okay, it's the same here. Number of week times, this is a times problem, the $40 she saves each week, but you have to add that to the $200 she had to begin with. So these are the two expressions, and then explain why Bettina's savings will never catch up to Sadie's. Well, you can say, well, she's already behind. She'll never catch up because she's only saving $25 and she's saving $40 every week. You can say that here, yeah? Or I'm going to show you with formal algebra. They're talking about formal algebra. Okay, so you can say, when will the two expressions be equal? Formal algebra can say, when will both have the same amount saved? Okay, now what that means, when will both expressions be equal? These two. So that's what we're looking for. When will both expressions be equal? And then we're setting up an equation. Because equal means equation. Something is equal. So say 200 plus 40W, when will that be equal to the other expression? And remember, W is the number of weeks. So whatever we get for W, that would give us the answer when they have enough, when they have saved the same amount. Okay, so let's solve this equation. And we practiced in class solving equations. So let's see, we start with a line. I see people doing that. That's a great start. Let's look at the W. I'm going to subtract 25W. That's my choice, how I'm starting. $200. 40 minus 25 is 15. W. Subtract the 200. 15W. 150 minus 200 is negative 50. Divide both sides by 15. W is a negative answer and it's 3.5. So let's remember, W is the number of weeks when they have the same. Is that possible? Can we have a negative number of week? When the number of weeks is a negative number, They will never have the same amount of money because there's no negative weeks. Okay, so the reason is because our variable is a negative answer. W means the number of weeks they need to save to have the same. Makes no sense to have a negative number of weeks in the context of our problem. Therefore, that will never happen. This is formal algebra. You can also say that she's always going to be behind because she only saves $25 and Sadie saves $40. So there's no way she's going to catch up. But this is the proof. This is the formal algebra is the proof. Okay, copy that. And we're going to the next page. This was page 12. You always want to stop your video. You want to rewind. You might want to watch it once without taking notes and then write it down afterwards. Sometimes that makes more sense to you. So it takes a little extra time, I agree, but you want to learn the math rather than just get it done. So we're moving on to number 13. That's all notes. More savings problems. So savings, money, that's called applications because this is real life. We want to save money. Okay. Use the following organizational structure. This means you're organizing your work, and that's always a very good thing in math, to be organized to solve these problems with algebra. So we're using formal algebra to solve it, which means setting up an equation and solving it. Here are the steps. We always want to identify a variable. If you look at the previous page, I wrote W is equal to the number of weeks they're saving. So I let my variable, I pick a letter, W works. They actually told us W in the problem somewhere. Can't remember where. Did it say anything? Nope, I don't see it. But I use W for weeks because that's a good reminder what W is, but you need to write it down. Okay, so that's called identifying a variable. And so we're going to do that each time. Then we have to write an equation, solve it, answer the question with a sentence usually, and then check your answer. And I'm always lacking on that last part, but it's a good study habit to start, okay? So let's read number one. I always like to underline what's important. Sven is saving for a $680 phone, taxes included. He has, so this is your total amount he wants to pay for his phone. He has already $118 to start with. This is your start, and will save $35 per week. Now here's the thing. The question is going to identify to you what are you looking for, and that's your variable. So let's look at the question. It's usually at the end of the word problem. After how many weeks? So what are we looking for? Weeks. Yeah, the question is, tell me how many weeks. So of saving will we be able to purchase the phone? So that right there tells me my variable. After how many weeks? So I'll say let. I like to use the word let because it's your choice. I'll use W again as number of weeks. This is not hashtag, this is a number symbol. He saves. So he has to save a certain number of weeks, and that number W will tell us that. Okay, this is called identify a variable. So I've done that. Now we have to write an equation. So let's look. start out 108. Oh no, 118. Start out point. Okay. And then he saves $35 per week. Saving means you're going to add more, $35 each week. So let's W 35 times each week, added to 118. And now he wants to pay 608. He needs that $608. So this is our equation. Now we need to solve it. If this is a little tricky for you, stop the video, look at it again. Subtract 118. $35W equals 0.9. Is it 490? I think so. Divide by 35 and use a calculator. Don't erase your W. That's the number we need. 490 divided by 35. Let's see. 14 weeks. Remember now, let's look back. What does W stand for? W is the number of weeks he saves. So that's a good start to answer our sentence. He needs to save 14 weeks to get that phone. And last, so we answered the question and I'm going to check. So 14 times 35 plus the 118 should be 608. So 14 weeks, each week $35 plus what he started with. 14 times 35 plus 118 is indeed $608. Check. Okay. I just reversed it. If you're like, well, why would she start with 14? I used this, but I flipped it. It's okay. Adding means when you add something, you can flip it. So I multiply this first. You could still do it this way. 118 plus 35 times 14, and it'll also should give you $608. The key is he needs to save for 14 weeks for his phone. Okay, let's do number 2. Ben is saving for the same phone. So that's also $608, correct? That's probably why this is here, and wants to buy it at the same time as Sven. Ben already has $73 starting point, right? And will save the same amount each week. How much? Here's the question. This is where you identify what you're looking for. This is your variable. How much should his weekly savings be? So when it says how much, am I looking for a week or am I looking for a dollar amount? I'm looking for a dollar amount. How much is always, well, is savings. How much is telling me how much am I going to save each week to make it at the same time as when with just $73 per week. So this is where I identify my variable. So I'm going to say let, and I can pick any letter. I could say A. How about A is the amount Ben has to save each week. And it's always good to spell it out correctly, because when you find your answer, then you can just say, oh, well, what did my answer mean? Go back here and read. Because sometimes we have to think, what is that? What am I even looking for? By the time you're done, you're so happy you got a number, but then you have to figure, what does that answer mean in context of the question? So let A is the amount of money I should have written. I'll just put a $sign above it. Ben has to save each week. So now comes my equation. So Ben has, what's his starting? 73 plus, we don't know how much he has to save, but I know he wants to save it at the same time. So I'm using 14 weeks. That's the same time, right? So I have to refer back to this. So, and we don't know, so 8 times 14, and he has to get $608 as well. But this right here does not look right. So I'm going to rewrite it the way algebra should be. It's 14a. Solve. So this is your equation. A times 14 is 14a in algebra. $608 minus 73. I used a calculator, 535. Divide by 14. Use a calculator. Oops, it says 38.2. I'm going to round it. So remember, so 38.21 because it's money. Remember A, because now we're thinking, oh, weeks. No, it's A is the amount Ben has to save each week. So now it comes back here where you can kind of remind yourself, what does this answer mean? He has to save, he should save. Now put a $sign, 2 decimals for dollar and cents each week for 14 weeks. If you check, so I'm going to check over here. I can say the 73 that he started with plus the 38.21 for 14 weeks should give me the money I need to buy that phone. Okay, let's try it. 78 plus 38.21 times 14. It might be a tiny bit off. Think about why. Think why. $607.94. Think about it. Why is it off? So he needs 608, but he got 607.94. Well, the reason is we rounded this money amount. We dropped off a bunch of decimals, correct? So therefore, this is going to be 6 cents under. That's all right. But it works, okay? Rounding. Made it off. I'm not gonna write anything. I'm hoping you understand that. Okay, number 3. By the way, we're not doing number 4. Do we? Well, maybe. Okay, number 3. Because the Philadelphia Eagles won Super Bowl, that's 52, I believe. 5 for 50. L means 50, and this is 2, 52. Their ticket prices are going up for the 2018-19 season. So going up, right? I'm always kind of thinking, more expensive. Barry and Ryan are eager to buy some tickets. Barry has $400 saved already. That's his starting point. And starts to save another $20 per week. In your mind, already think, what's that expression look like? Okay. At the same time, Ryan starts to save $40 per week, but oh, it's a girl. She has $100 debt. So that's a negative 100. Debt means negative number. Yeah. To pay off to her brother first before the savings are truly hers to keep. After how, okay, here's the question, underline it. This is what the variable, this is where you identify your variable. After how many weeks? There it is, after how many weeks of savings does Ryan catch up to Barry? So remember, first thing, identify your variable. Let, you can also make a L like this. You don't have to write it like me. Let W mean the number of weeks when she catches up. To Barry with her savings, right? So I identified my variable. I called it W because it reminds me it's weeks. You can call it X, Y, Z, whatever you want. Okay, but you got to write down what the variable represents. Then we write our equation. So let's think. Barry started out with $400 and he's saving, so it's adding $20 a week. And that should equal, because when they have the same, that means both expressions are equal, but the gal has $100 debt. Remember, that's a negative 100, and she's saving $40 per week. So there's our equation. Now I want you to save that yourself, work it out yourself. And I'm just going to put the answer so you can pause the video, see if you can figure out W. That should be a good exercise for you. And I will just put the answer down. Please pause. You do need all the work here. Okay, you should have W is 25 if you did it correctly. So that means, let's see what our W means, number of weeks when she catches up to Barry. She has the same amount after 25 weeks. I'm going to skip this one and use this column over here, this little space to check, because I never show you how to check really, really good. So 25 weeks. So let's see. So what is Ryan got? What is Barry got? After 25 weeks, Barry started out with 400 plus he saves $20 and 25. Let's see, what would that be? 400 plus 20 times 25 is 500. 400, so they have $900 after 25 weeks. And then the gal, Ryan, she starts out with negative 100 in debt, and then she saves $40 a week for 25 weeks. So it's negative 100, 40 times 25 is 1,000. So 1,000 take away 100 is 900. See how they both have the same after 25 weeks. So this is the number of weeks. And they both have $900. And that's how you can check. Very good. This is page 13, guys. Make sure you copy it correctly. Try to make some sense out of it. So when you study math, sometimes you have to go through it one more time, like I always say, and kind of look from step to step. And there's always some hurdles that you're not sure why that happened or what did she do that for. And those are the things that with more experience, if you do more and more math over your career in school, you'll become more familiar with. Okay, so don't feel like you're not as smart as somebody else because you're going to get those hurdles done as well. But you do have to put some effort into it. So that was page 13. And now page 14 is called perimeter. What is perimeter? Perimeter, this is in geometry. Perimeter is when you walk around a shape. Like let's say this is a garden plot. So the perimeter is if you start walking here, 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 you walked around the perimeter, the outside, but you have to add up all the sides. So let's write that. It's the outside of a shape. And so you add all the sides. Again, we're going to do the same thing, use the same organizational structure as the previous page to solve the following problems. We're going to identify a variable, which is going to be a little trickier in this. We're going to write an equation, solve it, answer the question, check your answer in the original problem. That's another thing. You always want to go back to the original, to the top, and check your answer. This rectangle and this triangle have the same perimeter. When it says same, it's usually where your equation equal sign is. Yeah, that's always the indication. This is because remember, you do have to write an equation. The same means equal. What is the perimeter of each? This is the question. What is the perimeter of each? So that tells me my variable. So I'm going to say, let P be the perimeter of each shape, right? That's what they're saying, each shape. Rectangle, triangle. Okay, now I have to write an equation, but the perimeter is all sides, so there's something missing. This side is called x. This is x minus 3. This is x, and this is x minus 3, because it's a rectangle. So now I have to add all these sides. So I'm going, remember the equal, this is equal to that. So x plus x minus 3, that's actually 2x minus 3. 2 groups of x minus 3 can be written like that. And then over here, this side, this triangle, x plus 6 plus x minus 2 plus x plus 3. So all we know is that this is the side length. You don't know what x is yet. We will find it, but that's, you're just adding these expressions. These are expressions, okay? So now we have to simplify. So that needs to be multiplied. X plus x is 2x plus 2 times x is 2x. 2 times negative 3 is negative 6. X, 3x. 6 minus 2 is 4. 4 plus 3 is 7. So we still have to combine the x's over here. 4x minus 6. Now we can start shoveling things around. I'm moving the 3x to the other side. This is a big problem. There's no room. 4x minus 3 is x. Add 6. X equals 7 plus 6 is 13. Okay, what are we looking for? We're not looking for x, we're looking for, oh shoot, I didn't. No. You see how much trickier this is? P is the perimeter, but I used x. X is not the perimeter. Okay, we're gonna adjust this. I'm going to fix my let. Maybe somebody can think. I used x. What does x mean in my problem? This is why you use pencil for math. Let x, since I used x, what is x? Think about it. Length of rectangle. This is x. So in this case, we're not going to use the question. Remember I said it's a little trickier with these. We're not looking at the, we're going to have, this is my intermediate step. So x is 13. That means this is 13 and this is 13. We're still having to look for the perimeter of each shape. So x was the length, that was 13. X minus 3, 13 minus 3 is 10. The width is 10. 10, and then x minus 3, 13 minus 3 is also 10. So we can find the perimeter, and then here we can plug it in. X is 13, x is 13, 13. So now let's find the perimeter. This is where the question is. Perimeter, 13 plus 13 plus 10 plus 10. 2 times 13 plus 2 times 10. I'm going to put a little rectangle here. That's the perimeter of my rectangle. That's 26 plus 20. That's 46. And then the perimeter of the triangle. 13 plus 6 is 19. Plus 13 minus 2 is 11. And 13 plus 3 is 16. 19 plus 11 is 20 is 30. 30 plus 16 is 46. The perimeter of each shape is 46. Very, very tricky questions. I'm going to have you guys think about this. We're going to do another one. Number 2, I'm going to erase this so I'm not running into the question. You might want to pause and copy because in a second it'll be gone. All right. In a rectangle, there's our rectangle. The base is 5 units more than its height x. So they call this base and height. This is your base, and this is the height. You could also call it length and width. I'm not going to write that there. You don't have to. I just wanted you to see it. In most problems, it's called length and width, base and height. Okay, so we call the height x. In a rectangle, the base is 5 units more than the height. So that would make it x plus 5. 5 units more than the height x. Twice the height is equal to the base. Remember the word equal or the same, that indicates your equation. So first of all, let's identify a variable. So let x be the height of triangle, of rectangle. But what are we really looking for? We're not looking really for x. That's just an intermediate step to get us to the answer. What are the dimensions and its perimeter? Now, dimensions, it's base and height. They want to know the base, the height, and the perimeter. But in order to do that, to find that, we got to find x first. Okay, so here's our equation. You have something is equal. Twice the height, 2x, is equal to the base, equal to the base. Okay, let's read that again. Twice the height, x, twice 2x, is equal to the base, x plus 5. Let's solve that. You have 2x minus 1x is simply x is 5. Very quick equation. Now we know that the height is 5 and the base is x plus 5. Well, x is 5. What's 5 plus 5? It's 10, correct? So 10, 5, 10, 5. So now we can find the perimeter and we know the base and the height. So here's our answer. The base is 10. The height is 5. And we also want to find the perimeter. Five plus 10 plus 5 plus 10. 5 plus 10 plus 5 plus 10, which is 30. Okay, I think we answered it. Yep. We wanted the dimensions, the base and the height, and we needed the perimeter. Okay. Last one, I'm skipping number 4. That's the one. This last one, this number 3 is very, very tricky. But I'm skipping 4 because I think this will take every ounce of energy you have out of you. An equilateral triangle sits on top of a rectangle to form a house. What does equilateral mean? It means all sides are equal. So if this side is x, this side is x, and this side is x. That's what equilateral means, okay? The height of the rectangle, this is your height, is 6 units less than the base. The base is also x because it's a rectangle. 6 units less means the base minus 6. The perimeter of both figures is equal. That's our equation. Remember, something is equal. The perimeter of this, perimeter of triangle. I'm going to write it out and erase it just so you see it. Actually, you know what? Symbols is good. I'm going to just show it to you in symbols. The perimeter of the triangle is equal to the perimeter of the rectangle. That makes sense to me because it says the perimeters of both figures are equal. Okay, so now let's identify a variable. In this case, our question is, what is the perimeter of the house? So I know that's what I eventually have to answer, but to do that, I need to find x. So I'll say let x be the base of the house, because that's what I could also say it's the side of a triangle, but I'm just making it short. Here's the equation. Perimeter of the triangle is x plus x plus x. Perimeter of triangle, x plus x plus x is equal to the perimeter of the house, the rectangle. X plus x minus 6 plus x minus 6. So I start here, add this, add this, add this. 3x, 1, 2, 3, 4x, minus 6 plus minus 6 is negative 12. So I simplified my equation. I'm going to choose to subtract 4x. I want to show you something. Eventually, you're going to run into it. What is if I say I want to subtract 3x from both sides, just to show you what happens. What is on this side? Nothing, right? Make it a 0. 4x minus 3x is x minus 12. Add 12. That'll happen sometimes. I don't want you to be sitting around going, well, what happened? 0 plus 12 is 12. So x is 12. But that's just our intermediate, because what is the perimeter? 12, 12. Oh, it's the perimeter of the whole house. Be careful, we only want the outside. Remember, perimeter is only the outside. Not that. That does not count as perimeter. So I'll make it green so you really see it. So we need to figure out what each side length is. Well, this is 12 because it's labeled X, but now what do we have down here? That's 12. That's a X, and it says X is 12. But this is X minus 6, so that's a 6, and that's a 6. Because 12 minus 6 is 6. So now the perimeter, 12 plus 12 plus 6 plus 12 plus 6. And then I'm going to count 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5. And now I'm going to add them. 24, 30, 42, 48. Whatever the units are. I'm not sure, meters. Don't know what they're measuring this in, so I'm just using the number 48. Very good, guys. This is a little tricky here. You have to know how to read. You have to know how to understand what you read, translate it into math, and able to answer the question. So this is very, very hard. Lots of steps. If you're not ready for this, do not worry. You're not a bad math student. You're just going to step back and say, that part I did not understand. It happens all the time. We're going to weed out what we understand from what we're not understanding. Okay, so next page, this was page 14. And this one we skip. So write skip on top. You can cross it out if you like. Let's see if I wrote notes. Yep, this one needs to say notes. I'm just checking, make sure I have something on top of each page. Yes. Skip that one. And now this one, page 16. We're going to do notes plus homework. This is the one with the fractions I wanted to show you. Equations involving fractions, rational numbers. So I'll call it fraction buster. I'm going to show you fraction buster. So I'll say use fraction buster. We're going to get rid of these fractions. So on these, this is homework. 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 These are huge. Homework. I want to show you this one. These you just use a calculator for sure with those decimals, but I'm going to show you what you can do to get rid of the decimals. Definitely I'm showing you these two, okay? Fraction buster on these. Don't write that yet, later maybe, okay? Because I want to have some room. This one with the decimal, a quick way is, since you have one digit after the decimal point, move your decimal 2 spaces, but that means you have to multiply everything by 10. So now that turns into 50x plus 4 equals 2 times 10 is 20x plus 7. That's an option to get rid of the decimals. Or you can just use your calculator and do it the same way as you would normally solve this equation, okay? But this is an option. Remember, if you move your decimal 1 space, you got to multiply everything else by 10, because that's 1 space is multiplying by 10, everything else. Otherwise, you're changing the equation. With this one, you could, let's multiply it out. You can use a calculator. 0.2x plus 0.2 times 0.3, I believe, is 0.06, but let me try it. Yep, 0.06. Not 0.6, don't be hasty. Minus, this would probably be 0.04. Yep. Okay, now if you want to just continue with your calculator and solve that, that's fine. But if you want to get rid of the decimals, notice the biggest one, you're moving it twice. That means you have to multiply by 100, or you're moving everything twice. So you now have 20x plus 6. You're moving this one twice. That's 40x minus 4. So now you got rid of your decimals. If you don't want to do that, that's too tricky for you, just use your calculator and your decimals. Now these, I will show you fraction buster. It's a lot easier. So look at the bottom of the fractions, 8 and 4. Common denominator is 8, because 4 goes into 8. So you're multiplying everything by 8. Just put it on top in parentheses. Each part gets multiplied by 8. 8 times 6 is 48x minus 8's cancel out, 1. 8 times 4, 32x plus 8 divided by 8 times 1 is 8 divided by 4 is 2. Now you don't have any more fractions. That's why they call it fraction buster. And now I'm solving. I subtract 32x 48 take away 32, I think is 16x. Add 1. 16x. 2 plus 1 is 3. Divide by 16. X is 3/16. That's a rational number. So your answer might be a fraction. It's not a big deal. Use 3/16 rather than dividing. If you divide 3 divided by 16, it'll give you 0.1875, which is a ending decimal, which is also a rational number. But this is much more accurate. 3/16 is okay. The part up here that's tricky is probably getting rid of the fraction. Let's look at this one. So your fraction, you look at the denominator. Lowest common denominator between 2 and 3 is 6. Because 6 is divisible by 2 and 6 is divisible by 3. So now you multiply everything by 6. However, you do not have to multiply this because the 1/2 takes care of that. Don't multiply this because the 1/3 out front takes care of it. 6 times 1 is 6, divided by 2 is 3. Six times 1 is 6, divided by 3 is 2. So notice your fractions are gone. Okay, multiply that out. 6x plus 12 plus 1x is 18x plus 24. 6 plus 1 is 7x plus 12. 7 subtract 7x. 12 equals 18 minus 7 is 11x. Subtract 24. Negative 12. Divide both sides by 11. Negative 12 over 11 is an improper fraction. You can make a mixed number out of that. So that's negative 1 and 1/12. Wow, what a question. What a long problem. Now, if you do not quite get this yet, don't despair, but it's there. If you want to deal with the fractions, go ahead and do it. This might be easier to distribute 1/2. 1/2 times 2 and 1/2 times 4. 1/3 times 9 and 1/3 times 12. It'll actually give you whole numbers. So you can try that as well. But the answer needs to match. Okay, this was page 16. And now this page is homework. Page 17 is homework, and then we're done with our book. We got a review. I'm looking at this. This is cool. We might do that in class if we need 4 people though, 2 and 2, or 6 people, or 8. We need 2 and 2. So hopefully one day everybody's there. So goodbye, everybody. Have good luck with these equations.